Okay, so our last section for this week is 4.3. Okay, still talking about rational functions. What we're going to do today, kind of get away from some of the graphing and the heavy-duty sketching and solve more equations and inequalities. Some things we'll have to do with our calculator. Some things we'll do with algebra. All right. Right, that's just what we're going to do today. We're going to solve equations and inequalities that have rational expressions, okay, both algebraically and graphically. All right, our first problem, and we're going to use this problem throughout the lesson. We're going to kind of come back to it a couple times. It involves this formula. Okay, so you have to know this to do the problem we're going to do. And this is the formula for distance, rate, and time. Okay, your distance equals your rate times time. Right, now for the problem we're going to do, we're going to assume that our speed is constant the whole problem. Okay, in reality, that's probably not accurate. Speeds change a little bit. But just to simplify it, we're going to assume the same speed for the train the whole problem. All right, so this is in your book on page 236. It says Sue drove 30 miles to a train station. Okay, then from there, she got on the train and completed her trip. In all, the entire trip was 120 miles. Okay, we don't know the speed of the train or the car, but we do know that the train, on average, was 20 miles per hour faster than the car. That's it. That's the whole problem. Okay, so what they want us to find is an equation for the time it takes to complete the trip. All right, so she's got two modes of transportation here. One's the car, one's the train. So we're going to have to take the amount of time she spent in the car and the amount of time she spent in the train and do what with them? Add them up. That's the total time. Okay, so let's just start with that. Okay, total time. It's just kind of a formula for the big idea. Total time equals time in car plus time in train, or on train. All right, and we've got to use this formula somehow to find time. Okay. If you have your distance, your rate, and your time, how can I rearrange that to get t equals?
Divide by r.
Yeah, distance divided by rate equals time. All right, so if we can find our distance in the car divided by the rate of car, distance divided by rate is time. Okay? And then we also have to find the distance we travel in the train, and we have to divide by the rate of the train. Okay, so if we can find how far we go on the train and how fast the train was going, distance divided by rate gives us time. All right, so we're going to find our time as a function of x. X is the speed of the car. So they're telling us what to use for the speed of the car. Okay, we know that. Let's go back and see if we have the distance we traveled. Yeah, we drove 30, or Sue drove 30 miles in the car. And the rate of the car? X. Now we need the distance we traveled in the train. 90. The total trip was 120. She drove 30. The train was 90. Now the rate of the train. Yeah, it's 20 faster than the car. Well, the car is x. So if you want to go 20 faster, you go x plus 20. And there's your formula for the time to complete the trip as a function of the speed of the car. Right? So now you tell me the speed of the car. I can fill it in for x and then find out how long it takes to make the trip. Any questions on the formula? All right. So now let's look at that and do some of the stuff we normally do with it. Let's find some asymptotes, find some zeros. They're not asking us to sketch by hand. Find a complete graph means use your calculator. All right, so let's start with vertical asymptotes. If you have two separate fractions, sometimes you need to put them together with a common denominator. To find vertical asymptotes, you don't. Okay, for this part, we don't. What would be my two values that would make the denominators 0? Yep.
0 and negative 20?
Right. Now, in this problem, maybe negative speed doesn't even make sense. So maybe there's no real world application to negative 20, but it is a vertical asymptote in the equation. All right, let's find our horizontal asymptotes. Okay, for that, we need to put the equations together. Okay, what's the trick I said you could use to get a common denominator? Not cross multiply. I like the idea of multiplying.
Multiply each side over the left side by 20.
Well, what is my common denominator here?
Multiply each side by the other denominator.
Yeah, the common denominator is x plus 20. And then to get that common denominator, the first one is missing the x plus 20. So I'd multiply top and bottom by x plus 20. Right, so that's 30x plus 600. I'm going to write it up above because I'm going to combine like terms. I'm going to put my final answer down below. Okay, in the next one, multiply top and bottom by x and x. Okay, we already have it in the bottom. And so we get 120x plus 600. All right, now we can find our, let's find our end behavior model and horizontal asymptotes. Okay, what's the highest degree term in the top? Yep, 120 goes with it. And now in the bottom, I know it's not distributed out, but if you did it, what would be the highest degree term in the bottom? It would be x squared. So that's going to become 120 over x. Now, as x gets very, very big, what does this fraction approach? Yeah, it approaches 0. Okay, as you start dividing 120 by a bigger and bigger number, it gets smaller and smaller and smaller. All right, what else do they want? We've got our asymptotes, we've got our EBM, complete graph, oh, and the roots. Okay, well, we can get the roots, or the x-intercepts, just by setting y equal to 0. Okay, this is y, time. So what's the only way that a fraction could equal 0? If what? Not the bottom, but the top. Okay, so to find your zeros, which is really the x-intercept, set your equation equal to 0 and solve. Right? Which just means set the top equal to 0. Let's see. All right, so we get negative 600 equals 120x. Okay, and divide Yep, we get negative 5. Again, maybe no real world point to this number because x is our speed. Negative speed doesn't make sense. But it will cross the x-axis at negative 5. Okay, let's find a complete graph. Okay, to find a complete graph, I'm going to just type in the original problem. It's not that hard to type it in. 30 divided by x plus 90 over x plus 20. All right. As far as our window, I wouldn't look at negative speed. That doesn't make sense. Highest speed, let's maybe go up to 60. Okay? It doesn't matter. We're just trying to get an idea of the graph. Y is our time. Negative time, does that make sense? No. Okay, maximum time. Right now, we have 10 hours. Let's just see how that looks. Okay, so there's her speed, or there's her time. Okay? The faster, notice what happens, the faster and faster she goes, what happens to how long it takes? It goes down. Okay? And it can approach 0, but could it ever reach 0? No, because no matter how fast you go, there's always a distance you have to drive. It's going to take some amount of time, so it can never reach 0. Notice, though, at first, if she picks up the speed a little bit at first, her time goes way down. But then if she picks up the speed a little bit more, it doesn't go down as much. All right, so eventually, once she reaches a certain speed, it doesn't really make a difference if she goes 10 miles an hour faster. It's going to make a very, very small difference. But for slower speeds, it makes a big difference. Okay, so there's a complete graph. Okay, so for that, I would just put down your window. Okay, x min was 0. Okay, any questions on that? So now it says she has 2 hours to complete her trip. Find the speed she has to drive at. Okay, how would we do that? Yeah.
When you found the 0, why didn't you find the y-intercept?
Just because they didn't ask for it. When they ask for zeros, that's specifically x-intercept. But if they asked me for y-intercept, I would have had a problem with that. Because to find the y-intercept, what number do you plug in for x? 0. And if I plug 0 into the bottom, I'd have 0 times 20, which would be undefined. Okay, so in other words, this graph never crosses the y-axis. It just gets close to it.
So we don't know the speed of them yet?
Not yet, but in this problem we will. Okay, how would I find out how fast she has to drive if she's got 2 hours to complete the trip? Yep.
Plug in how long she has to do the trip and see what it intersects.
All right, plug in the time to do the trip. Yep, we got it on there. 2 hours, and then calculate the intercept. Right, so x is 46.4, and remember x was the average rate of the car. Okay, so she has to drive about 46.6 miles per hour. And if the train is 20 miles per hour faster than that, then the train is going about 66.6 miles an hour. But they didn't ask for the train. Find the speed. Right. We could do it algebraically if we wanted as well. To do it algebraically, okay, I'm just going to set it up, but we don't have to go through it unless people have questions. Plug in 2 right there. And I'm just going to multiply this out. Okay. You know what, maybe it's a good thing to go through just in case people aren't sure. Basically, what's going to happen is we get a quadratic equation. Multiply each side by x squared plus 20x just to get rid of that denominator. So on the left, we get 2x squared plus 40x. Does everyone see I did a distributive property with that? And on the right, the denominator would just be gone. Okay, so I multiplied each side by that. What's that? Yep. And now, because it's a quadratic, you want it equal to 0. Subtract 120x and subtract 600. All right, so I get 2x squared. 40 minus 120 gives me negative 80. And now I have a lot of ways I could solve it. Use quadratic formula, factor it. Okay, what did we get? It's probably not going to factor nicely because we get an answer of 46.6. So what I would do is just plug it into quadratic formula. This part, if you just want to watch it, that's fine. You could just watch this part. Because on the test, I'll give you the option of either doing it as a graph or with algebra. Okay. Just want to make sure people remember quadratic formula. All right, so we got negative b plus or minus the square root of b squared minus 4ac all over 2a. I just want to make sure when I do it, I get 46.6. All right, 80 squared. Let's see, that's 6,400. 4 times 2 is 8. 8 times 6 is 4,800. That's negative 4,800. But then those negatives become addition. Right, so plus 4,800. Take the square root. I get 105.83. So let's just write it that way. All right. I don't think I need to worry about the minus. How come? Yeah, what? Yeah, it's not going to be speed's not negative. So you wouldn't want to do 80 minus 105. That'd be a negative number. All right. So let's see what we get when we add 80 plus 105. Divide by 4. Okay, we got 46.5. I think graphically I got 46.6. That's just because of the rounding. Okay. Right. So I'm just showing you can solve it either way. Quadratic formula, not too bad. Kind of big numbers. But graphing, a little faster. Yep.
How much is on the rate of
The 2? 2. Yep. Whatever time they tell me, I fill that in for the time. Yep. Now, we did something in example 3 that we got to be careful about. Okay, we multiplied both sides by an expression that has a variable. Okay, I think I multiplied both sides by x squared plus 20x. Okay, anytime you multiply both sides by something that has letters, you can get what's called an extraneous solution. Okay, it's not that you did something wrong. It's just that what you might have now is an extra answer that doesn't work. Okay, by multiplying both sides by something with letters, you created a new answer that wouldn't work in the original problem. So what do? We just check our answer. Okay, if we get multiple answers, make sure they work. Okay? And you can see exactly how that happened in the last problem. Quadratic formula gave me 2 answers. Right? One positive, one negative. The negative answer doesn't work. Not in this problem. Okay, think about it in terms of a real life problem. You can't have negative speed. So just make sure you check for an extraneous solution. All right, but that strategy of multiplying by something with a variable, we use it a lot. That's how you solve rational equations. Okay, our goal is to get rid of all these fractions. Okay, fractions, it's hard to work with. If we can get rid of them, we're going to end up with a problem just like we had. Always going to end up with a quadratic. Sometimes you'll factor it. Sometimes you'll use the quadratic formula. Okay, so our goal is to eliminate the fractions using the LCD, okay, the least common denominator. And remember the trick I told you for finding it. Okay, you just take the two that you have and multiply them together. Okay, if you look carefully at x minus 1 and x minus 3, if you multiply these together, what do you get? You get x squared, yeah? Negative 4x. And plus what? Plus 3. Notice if you multiply these two denominators together, you get the one that's over here. If I didn't do that, this problem would become a lot more difficult. All right? But that will always happen, and that'll happen on the test. This denominator is just these two multiplied together. Foil it. Foil it out.
How do you get 2? Yeah.
Foiling these together?
No, how did you only get 2?
Oh, the top is just the problem they gave us. I'm just saying if you take this times that, you get that. That's all I'm saying. Yep.
So that after when they're all on top of the same equation, the bottoms don't matter.
Now, the bottoms are going to be gone in a second. Okay, we're going to get rid of everything that's in the bottom. Okay, so what could I multiply everything by here that would cancel out all three denominators? Well, think about what would you have to multiply this first fraction by if you wanted to get rid of this denominator? No, not 1. X minus 1. Right, so we got to multiply everything. If you're going to multiply the first one by x minus 1, you got to multiply them all by x minus 1. Now, what if you wanted to get rid of x minus 3? What would you have to multiply by to do that? So if you're going to do it here, you've got to do it to all of them. Okay, so the trick is to multiply every fraction in the top by this denominator and that denominator. Okay, that's the trick. Multiply every fraction by those two denominators. Yep.
You said you foiled the x minus 1 and the x minus 3.
Yeah.
What happened with the top? Why is it just 2?
So if we FOIL it, we get x squared minus 3x minus x plus 3.
Yeah, but how can you have only 2 on the top?
Don't worry about the top.
Oh,
Okay, I'm just saying if you take this times that, you get that. That's all. Okay, so now we've multiplied every fraction by this denominator and that denominator. So what would cancel out in the first fraction? X minus 1. What would cancel out in the second fraction? X minus 3. And what would cancel out in the third fraction?
Oh, both.
Both. Remember, when you multiply these together, you get that. Right? So let's rewrite what we have now. We have 2x times x minus 3. We have 1 and the positive 1. If this was a negative right here, you'd be distributing a negative 1. Okay, but it's a positive 1 times x minus 1. And on the other side, it's just a 2. Do that out. What's 2x times x? 2x squared minus 6x. 1 times x? X minus 1. Okay, now get everything on one side and factor it or use quadratic formula. All right, so we got 2x squared minus 6 plus 1, minus 5. And then minus 1, I'm going to subtract 2. All right, let's see if we can factor that. Okay, I would need two numbers that multiply to give me 3. 1 and 3. And let's try, you want to try plus minus or minus plus?
Plus minus.
Yep, I think plus minus is going to work. 2 times negative 3 is negative 6. Plus 1 is negative 5. All right, so now we're going to get two solutions. What's the solution for the second factor? Yep, positive 3. You can put plus 3 or just 3. That's fine. And the second one? Negative a half. 2 times negative a half is negative 1. Plus 1 is 0. Now, there's 3 things that could happen here. These could both work. They could both not work. Or one works and one doesn't. Let's go back up and check 3. Okay, this original denominator was x minus 3. Can I plug 3 into that denominator? No, it would cause me to divide by 0. This is an extraneous answer. All right, so if you get this far on the test and you forget to cross this one out, you're going to lose 1 point. Okay, so make sure you cross that answer out. It doesn't work. The negative a half, if you plug it back into all the denominators, it works fine. Okay, so this is a case, one works, one doesn't. Okay, any questions on that one? Yep.
So on the test, will it give us the final equation on the right up on the top?
It will give you
Those two.
exactly what we started, just like this.
Okay, so
Yep.
we don't have to multiply the 2 on the bottom to get the denominator on the right?
Oh no, this will already be done out for you on the
Okay.
test. Yeah. Yeah. Okay. It could be something just like that. Okay. I've got the 2 denominators on the left. I will already multiply them to get the one on the right. Okay, so what would I multiply everything by here? Yep, I like x because that's going to get rid of this. And what else? And x plus 2 is going to get rid of it there. Okay, so here, x and x cancels. Here, x plus 2 and x plus 2. And what about on the right side?
Both.
Yeah, they both. Okay, so write down what you're left with. X minus 3, x plus 2, positive 3x. Be careful, if that was a negative, that negative goes with that 3. But in this case, it's a positive. And the other side is negative 6. Okay, this I have to distribute out. X squared plus 2, take away 3. That's a minus 1x minus 6. Okay, I'm going to combine like terms. Got my x squared. Negative x plus 3 is 2x. And what's going to happen to my negative 6? It's going to cancel out. So now this one's going to be very, very quick to factor. What do these both have in common? x. Just take the x out. And now we're done. We just have to write our two answers. Yep.
First problem didn't it start as negative 6x?
The last problem we did?
Negative 6. No, like, the problem that we were just doing, it started as negative 6x. I'm pretty sure.
No, that was just negative 6. If we go back, I better be able to put all this back, I hope. That was the original problem. Math on the fly. There we go. Okay. Are we back to where we were? Yeah. All right. So now, what would be my two values here that would make it? First factor 0.
0 and
Negative 2. Let's check them. Can I plug 0 into the original?
Nope.
Nope. Can I plug negative 2 into the original?
Nope.
Nope. So what that means, there's no solution. Okay, this is the case where both answers didn't work. Okay, no solution. All right, and the last part of what we're going to do today, we're going to do a little bit on the calculator, some by hand. I just want you to read that carefully and focus on what the difference is between this problem and all the other ones we've done.
Is it more than?
Yeah, this one says what?
Less than.
Less than. What kind of problem do you have if it's a less than? A what? Sometimes we can mean less than, but if I said, for example, I have less than $10 on me, I wouldn't use an equal sign. That would be what kind of sign?
Inequality.
That's an inequality. All right? So now, we're not looking for an exact time. We just are an exact speed. We want to know if she wants to complete the trip in less than 2.5 hours, how fast does she have to drive? Well, we're going to find a certain speed, or she could go faster. So it's going to be any speed that we find or faster, okay, to complete the trip in less than 2.5 hours. All right, so if you still got it typed in, just change 2 to 2.5. Okay, there's her speed. There's 2.5 hours. So for her to complete the trip in exactly 2.5 hours, she'd have to drive 34.9. So she can drive 34.9 or faster. She can't go slower than 34.9. If she slows down, her time is going to go up. All right? So she has to drive at a minimum of 34.9 miles per hour, or she can go faster. So let's say it like this. Did it say less than or equal? Yeah, it said just less than. Okay. Definitely want to see why the final answer is greater than, though. She has to go at this speed or faster. Okay, and that's how we can solve an inequality graphically. Okay, just like with equations, you can always have hidden behavior. Okay, we know that. Always check for things that are off the screen. You know, that kind of stuff. If we're going to solve by hand, one thing we can do is make a sign chart. Okay, for our purposes, though, I don't think we're going to solve them by hand. Okay, we're going to just do it graphically. Now, I'm telling you, if you're going to do it by hand, you'd have to use a sign chart. When you have an inequality, why can't you just multiply both sides by something with a variable? Right, we don't know about the flipping of the sign. Okay, if you gave me this problem, let's say, and you said, oh, well, you want to get rid of your denominator. Just multiply both sides by x squared minus 8. Well, I have a problem if I do that. I don't know if x squared minus 8 is positive or negative. If it's positive, I wouldn't have to do anything to the sign. If it was negative, what would I have to do to the sign? Flip it. But there's no way to know. You have a variable. Okay? That's why when you're doing inequalities, you can't use the same technique as with an equation. You don't know if you should flip the sign. That's where the sign chart would come in. Okay? And we've done that before. That's where you make a number line. You identify where it's positive, where it's negative. People remember doing those charts? Where it's positive, where it's negative. And we usually have to make a couple of them. Okay, but let's just try it graphically. Okay, we'll do this one graphically, this one, and that's it. Okay, hardest thing here is just typing it all in carefully. Right, so we got, let's see, 2x squared plus 6x minus 8. 2x squared plus 6x minus 8. Okay, divided by 2x squared plus 5x. Okay, and I'd use parentheses. 2x squared plus 5x minus 3. Okay, so I'm going to put that in y1. And what am I going to put in y2? 1. Okay, and what I'm looking for is where my graph in blue is below my graph in red. Right, so that's our window from the last problem. Let's start with a standard window. Okay, we've seen that shape. That's kind of one of our standard graphs. All right, well, it's definitely not in the middle section. Okay, the graph in blue is above. But it looks like in each section here, the left section and the right section, the graph in blue is below. Okay, what I'm going to do is just zoom in a little bit. Okay, let's focus on that part there. Okay, let's just see if it crosses. I don't think it does, but zooming in will show me that. So let's go up to 2 and 0. I think that'll be good. Okay, so where is our graph in blue below red? Oh, actually, it does cross right there. All right. So on the other end, I don't think it crosses. Okay. I can check that very easily. At negative 10, nope, it's still below. Negative 50, yep, still below. Negative 500, still below. Okay, so I wouldn't worry about the left end. So the graph in blue is going to be below from negative infinity up to, what does it look like this vertical asymptote is at? Negative, yeah, I'd say negative 3. Okay, you can check it, see if you get an error. Sure. Okay, so up to negative 3. It's below. In this middle section, it's never below the red. And now in this right section, well, let's look at that. And let's see where it crosses. Okay, so up to that point, the blue graph is below, but then it looks like it does go above. What does it look like my other, I would have to find this other vertical asymptote. Yeah, let's just see if it's at 0.5. Yeah, it is. I wouldn't give you one that would be hard to find graphically. I wouldn't give you one that's like 0.5367 as an asymptote. Right? That wouldn't be nice. So it's at 0.5. And it's going to stay below up to, let's find this intersect, 5. Okay? Again, I'm not going to give you messy numbers to work with if I'm having you do it graphically like this. Okay, so that's where the blue graph is below the red. Okay, any questions on that? All right, and this one, does anybody want me to do one more on the calculator? Think we could do it? Okay. All right, it'd be the same basic idea. All right, so the homework, it's on 244. Okay, it's 1 to 9, just the odds. Then it kind of skips around, 11, 13, 20, 22, 24, 28, and 31. Okay, we'll go over that first thing tomorrow. Then we'll have our test on sections 3.7 to 4.3. Okay, there will be a bonus question on the test. Okay, and I will also be after school for extra help.